Unity uses materials, shaders, and textures to display 2- and 3-dimensional models. The model has one or more materials, and each material uses a shader. The shader used by the material is written in Unity's own language called ShaderLab. Within this, CG and HLSL code is also used. The shader exposes certain properties that are set by the material. It contains code that calculates how an object should display on screen. To understand shaders, you first need to understand what makes up 2- and 3-dimensional models. Models are meshes made up of triangles arranged in space. Each mesh requires several pieces of information in order to display correctly. Vertices, which give the triangles positions in 3D space. Triangles, which join up the vertices to create the model. Normals, which allow lighting to shade the model. UVs, if you want to map a texture onto the model. Tangents, if you want to add a normal map to the model. Colors, if you wish to use vertex colors. The model always needs at least its vertices and triangles specified. Vertices are the corner positions of 2- and 3-dimensional models. In Unity, the vertices are stored in the vector 3 array, with x, y, and z corresponding to the x, y, and z coordinates of that vertex. Triangles are used to join up the vertices in a model. In Unity, the triangles are stored in an int array, with every 3 entries corresponding to a single triangle. The order of a triangle's indices also gives a direction, clockwise or anticlockwise. A triangle drawn in 3D space will have an order, which is clockwise on one side and anticlockwise on the other. The anticlockwise face is not usually visible due to something called backface culling. It's the shader model that culls the back faces or not. Usually only one face should be seen, so the back face does not need to be rendered, as this would double the number of triangles rendered in scene. Assigning triangles and vertices alone to a mesh give the model a shape. Further information is needed to shade and colour the model correctly. This is where normals, UVs, and tangents come in. Normals are used by the model shader to correctly light each surface. Normals are perpendicular to the surface of a model. They are stored in a vector 3 array with x, y, and z corresponding to the normal's direction. UVs are needed if you want to map a texture onto a model, and UVs are stored in a vector 2 array. Assigning values to the UVs array tells Unity which bit of the texture goes where on the model. Tangents are required for the model to display normal or bump maps correctly. They are stored in a vector 4 array with x, y, and z corresponding to the tangent's direction, and the W component is used by Unity to calculate the direction of the binormal, a vector which is perpendicular to both the normal and the tangent vectors. The tangent vector itself is perpendicular to the normal, and is aligned along the direction of the x component of the UV at that vertex. Vertex colors allow the model to be colored in by assigning colors to each vertex. To display them, an appropriate shader must be used that makes use of them. They are stored as a color or color 32 array. Shaders can take any of these aspects of a mesh and use them to change how they are displayed on screen. This can be anything from the movement of vertices to adding an outline to changing how lighting affects an object. We'll look at both types of shader used by Unity in this course, surface and vertex and fragment.